So guys, in this lecture, till now we have discussed about Thomson's plum pudding model, alpha ray scattering, Rutherford's atomic model, and now we are going to discuss about the representation of an atom. First is atomic number. Now atomic number is the number of protons present in an atom. So what he is saying, the atomic number of an element is equal to the number of protons. So it's the number of protons present in an atom in the nucleus of the atom or the number of extranuclear electron. It means that number of protons is equal to the number of electrons if you are talking about atom, and this is generally denoted by Z. So atomic number Z is equal to the number of protons, that is equal to the number of electrons. Now mass number. Mass number is the sum of the number of protons and the number of neutrons present in the nucleus. And he is saying the total number of protons and the total number of neutrons in the nucleus is called the mass number. And one more thing, one important thing he is telling us, the number of protons and the number of neutrons collectively is called the number of nucleons. So whenever he say that number of nucleons, means you have to add those number of protons and number of neutrons, and it is generally represented by the letter capital A, and the mass number is the number of protons plus number of neutrons is equal to the number of nucleons. Now representation of an atom. Suppose the symbol of an atom is X, we will write the mass number at the top on the left hand side and the atomic number at the bottom in the left hand side. In short, in different numericals or some books, you will find that we write in short Z is equal to P and A is equal to N plus P. P is the number of protons and A is the number of neutrons plus number of protons. So let's discuss some more important terms. First is isotopes. Isotopes are those species which have same atomic number and different mass number. And he is saying each of the two or more forms of the same element. Now, every element is judged by its atomic number, not by mass number, right? So they have equal number of protons but differ in the equal number of neutrons. For example, carbon 6 and carbon 14. You can see that their atomic numbers are same, therefore elements are same and their mass numbers are different, so they are called isotopes. Next is isobars. Now if you talk about isobars, isobars are those species which have same mass number but the different atomic number, and if the atomic number is different, means the elements are also different. And he is saying the isobars of the atoms or different elements that have the same mass number of nucleons, means the number of nucleons are same, means number of protons plus number of neutrons are same, but the atomic numbers are different. So isobars will have the different atomic number. For example, calcium and argon. Calcium, we know that the atomic number is 20, argon we know that the atomic number is 18, and their mass numbers are same. You can see that the mass number of calcium and the mass number of argon is 40. Next is isotones. Isotones are those species which have the same number of neutrons. The two species having the same number of neutrons is isotones, and example is oxygen 16 and carbon 14. So what we can do, we can find out the number of neutron here. If we solve for this oxygen, the number of neutrons N, that will be equal to 16 minus 8, and that is equal to 8, right? This is for oxygen. So for oxygen, I am finding the number of neutrons. If I find for carbon, that is carbon 14, the number of neutrons will be equal to 14 minus 6. So it is 14 minus 6. So 14 minus 6 is equal to 8. So you can clearly see from here the number of neutrons present in oxygen 16 and carbon 14 is same. They are isotones. Next term is Iso-Diaphres. Iso-Diaphres are those species which have the same isotopic number. And what is isotopic number? We'll just discuss about it. They have the different atomic numbers and mass number, but the same neutron access. The meaning of the neutron access is the difference between the number of neutrons and protons, and this is called isotopic number, and we can find the isotopic number by mass number minus twice of atomic number. For example, sodium and chlorine. Let's solve for sodium and chlorine. Now, if I solve for sodium, the isotopic number A is 23 and Z is 11. Therefore, 23 minus 2 into 11, that is equal to 1. Right? Let's check for chlorine also. For chlorine, it is 35. So it is 35 minus 2 into atomic number is 17. Therefore, it is also equal to 1. It means that sodium and chlorine are Iso-Diaphres. The next species or the next term is isoster. Isosters are those species which have same number of atoms and the same number of electrons present in it. So, according to definition, isosters are the species having similar size containing same number of atoms and electrons. For example, nitrogen and carbon monoxide. And if we take the example of iron, we can take azide ion, that is N3 minus and NCO minus. Let's find out how they are isosters. So, if I take example of nitrogen for N2, the number of atoms are 2 and the number of electrons are 14. So 14 and 2. So what is 14? 14 is number of electrons and 2 is number of atoms, right? For carbon monoxide, now the number of electrons present in the nitrogen is 7 plus 7 is equal to 14. The number of electrons present in carbon monoxide is 6 plus 8, that is again 14. And number of atoms, one carbon atom is there, one oxygen atom is there, therefore the number of atoms is equal to 2. Right? So I hope you understood everything pretty well. Let's solve some numericals. Now guys, in this question he is asking, find the radius of the nucleus of aluminum atom. Mass number of aluminum is 27. This is given to you. Now I am pretty sure this is a new kind of a question for you, but these type of questions can come in competitive exams. Let's solve it. The solution will be, Now there is a way to solve these type of questions. There is a formula to solve these type of questions, and the formula is the radius of the nucleus, that is r, is equal to r naught multiplied by a power 1 by 3. Now this a is mass number. So what we have to do here, we have to find out the value of r. This is unknown. R naught, you have to keep in mind, or they will give you in the data, it is 1.2 into 10 to the power minus 15 meters, right? Now keep this in mind, okay? And A is also given to us. The value of A, that is mass number, that is equal to 27. Now let's solve it. So R is equal to R naught multiply by A power 1 by 3. And what is the value of R naught? It is equal to 1.2 into 10 to the power minus 15, and we have to multiply by 27 power 1 by 3, right? So solving it further, it is 1.2 into 10 to the power minus 15 into, now we have to find out the cube root of 27, and the cube root of 27 is 3. So putting the value of the cube root, it's equal to 3, and our final answer will be equal to 3.6 into 10 to the power minus 15. So 3.6 into 10 to the minus 15 meters is the final answer, right? Let's move ahead.